Okay, hopefully my tool is working now. But anyway, so we were saying when x is equal to minus 0.001, so we're getting closer and closer to 0 from the negative side, f of x is equal to minus 1,000, right? You can just evaluate it yourself, right? And as you see, as x approaches 0 from the negative direction, we get larger and larger, or I guess you could say smaller and smaller negative numbers, right? You get, if it's minus 0.0001, you'd get minus 10,000, and then minus 100,000, then minus a million. You can imagine the closer and closer you get to 0. Similarly, when you go from the other direction, when you say when x is 0.01, there you get positive 100, right? When x is my thing is frozen again, and it's 0.001, you get positive 1,000. So as you see, as you approach 0 from the negative direction, you get larger and larger negative values, or I guess smaller and smaller negative values. And as you go from the positive direction, you get larger and larger values. And let me graph this just to give you a sense of what this graph looks like, because this is actually a good graph to know what it looks like just generally. So let's say that's the x-axis. This is the y-axis. Change my color. So when x is a negative number, right? As x gets really, really, really negative, right? As x is like negative infinity, this is approaching 0, but it's still going to be a slightly negative number. And then as we see from what we drew, as we approach x is equal to 0, we asymptote and we approach negative infinity, right? And similarly, from positive numbers, if we go out to the right really far, it approaches 0, but it's still going to be positive. And as we get closer and closer to 0, it spikes up and it goes to positive infinity. And you never quite get x is equal to 0. So in this situation, you actually have, as x approaches, so let me give you a different notation, which you'll probably see eventually, and I might actually do a separate presentation on this. The limit as x approaches 0 from the positive direction, that's this notation here, of 1 over x. Right? So this is as x approaches 0 from the positive direction, from the right-hand side. Well, this is equal to infinity. Infinity. And then the limit as x, this pen, the limit as x approaches 0 from the negative side of 1 over x. This notation just says the limit as I approach from the negative side. So as I approach x equals 0 from this direction, right? From this direction, what happens? Well, that is equal to minus infinity. So since I'm approaching a different value when I approach from one side or the other, this limit is actually undefined. I mean, we could say that from the positive side it's positive infinity, or from the negative side it's negative infinity, but they have to equal the same thing for this limit to be defined. So this is equal to undefined. So let's do another problem, and I think, well, this should be interesting now. So let's say, just keeping that last problem we had in mind, what's the limit as x approaches 0 of 1 over x squared? So in this situation, I'll draw the graph. That's my x-axis. This is my y-axis. So here, no matter what value we put into x, we get a positive value, right? Because you're going to square it. If you put minus, so I mean, you could actually, let me do it. It'll be instructive, I think. So let's say, once again, obviously you can't just put x equal to 0. You'll get 1 over 0, which is undefined. But let's say, 1 over x squared. What does 1 over x squared evaluate to? So when x is 0.1, 0.1 squared is 0.01, so 1 over x is 100. Similarly, if I do minus 0.1, minus 0.1 squared is positive 0.01, so then 1 over that is still 100. Right? So regardless of whether you put a negative or a positive number here, we get a positive value. And similarly, if we say x is 0.01, if you evaluate it, you'll get 10,000. And if we put minus 0.01, you'll get positive 10,000 as well, right? Because we square it. So this graph, if you were to draw it, and if you have a graphing calculator, you should experiment, looks something like this. Hope you can see this dark blue. So from the negative side, it approaches infinity, right? You can see that as we get to smaller and smaller, as we get closer and closer to 0 from the negative side, it approaches infinity. And as we go from the positive side, these are actually symmetric, although I didn't draw it that symmetric. It also approaches infinity. So this is a case in which the limit, that's not too bright. I don't know if you can see it. The limit as x approaches 0 from the negative side of 1 over x squared is equal to infinity. And the limit as x approaches 0 from the positive side of 1 over x squared is also equal to infinity. So when you go from the left-hand side, it equals infinity, right? It goes to infinity as you approach 0. And as you go from the right-hand side, it also goes to infinity. And so the limit in general is equal to infinity. And this is why I got excited when I first started learning limits, because for the first time, infinity is a legitimate answer to your problem, which, I don't know, and on some metaphysical level got me kind of excited. But anyway, I will do more problems in the next presentation, because you can never do enough limit problems. And in a couple of presentations, I'll actually give you the formal kind of rigorous mathematical definition of the limits.